91 days until AS level maths at paper 1. Pause the video, have a go at this question and then we'll have a look at it together. Prove that root 2 is irrational. For this proof, we'll need to use proof by contradiction. So we'll start by saying that we assume that root 2 is rational. If root 2 is rational, we can represent this as a fraction, so for example a over b, where this would be a fraction in its simplest form, or in other words, a and b would not have any common factors. We can state that in its simplest form, a would be an integer, b would be an integer, and b cannot be equal to 0 since this is our denominator. To get rid of this root, the opposite of a square root is to square, so that's square both sides. Root 2 squared will just be 2, and a over b, if all of this is squared, will be a squared over b squared. Now to get rid of our denominator, we can multiply both sides by b squared, which would give us 2 times b squared is equal to a squared. Now if a squared is equal to 2 times b squared, no matter what b squared is, if it's multiplied by 2, a has to be a multiple of 2. This means we can now represent a by saying that a is equal to 2 times c, where c is just another integer. Now in place of a, let's substitute in 2c. We'll have 2b squared is equal to, in place of a we have 2c, and this is squared. Squaring this right hand side, 2 squared is 4 and c squared is just c squared. Both of these terms have a factor of 2, so if we divide through by 2, 2b squared divided by 2 is b squared, and 4c squared divided by 2 is 2c squared. Now if b squared is equal to 2 times c squared, it doesn't matter what c squared is, as long as it's multiplied by 2, that must mean that b is also a multiple of 2. So if a is a multiple of 2 and b is a multiple of 2, this means that 2 is a common factor of a and b. This is a contradiction of our first statement where we wrote root 2 is equal to a over b in its simplest form. Therefore, we can conclude that root 2 has to be irrational.